Thank you so much, Ashish, for joining us on this podcast at Doddle. We'll be touching upon a lot of pointers around your experience, especially in the payments space, which is a pretty interesting one. But before we go there, I would like to give a brief introduction about Ashish. Ashish is a seasoned engineering leader with experience in software development, platform engineering, and team leadership. He's currently engineering manager at Ingenico, where he drives the development of scalable, high performance systems, leveraging modern technologies like Docker and Kafka. With a strong foundation built at Comdell and Global Logic, he has progressed through multiple leadership roles, delivering complex projects, managing engineering teams, and architecting robust solutions across domains. He's known for his expertise in system design, delivery management, and process excellence, and he consistently enables team to build reliable and scalable technology solutions. Thank you so much, Ashish, for joining us on this podcast and taking off time.
Thank you. Thank you for introduction. My introduction.
So, Ashish, the first question, which is, I think, very close to you as well, is that you have spent years building backend and distribution systems, and now you are deeply involved in the payments ecosystem. So, what makes payments domain fundamentally different from the other engineering domains?
Basically, it's fair point that payment domain is little bit different than other engineering domains because of basically the nature of the business. Because wherever the money is involved as a transaction part of it, anything means stakes will be high. So you do not have any kind of luxury to do any kind of mistake. But I would not say only payment. If any system, any B2C system where the money is involved, any financial things are involved, all systems are using same concept kind of. When they built on, we built systems like that where the financial involved. Their system should be available. They should be kind of self-resilient, and they should be secure, as well as they should be performant enough to take the load of the millions of the transactions or millions of the transaction processing part of it. So when I see payment part of it, it is little bit kind of, when it comes as a part of from others engineering domains, it comes with the security because of there's some guidelines or regulatory guidelines are there, like in India RBI is there. Then it comes as a performance because you do transaction and you need a millisecond response from system. So when you design for that, so that is difficult to achieve that. Then you have the auditing part of it. So when you design the system, everything should be audited. So each and every system, because you have multiple stakeholders to manage using payment system.
Yes.
So you have the logs for them, like, okay, I sent this data and this is failed. So you design the system for failure itself.
Yes.
So that is the mainly difference between other system, because other system you can take a chance to fail it, but there's not kind of financial implication. But here, if you fail it, there will be implication, and if you partially fail it, there's a more than that, because your money will go, and other you can do anything with the merchants. So that's the difference, I think.
So, it's pretty high pressure as compared to the other engineering domains.
Yes, it is a more than because uh, so currently I'm working with the kind of, when we are designing this payment part of it. So payment part is uh, it took milliseconds basically to do a transaction, and when you are doing concurrent transaction, let's say 1,000 transaction within a 300 millisecond, then you need scale the system, as well as there should not be kind of, any service should not be going to down. If it is going down, it should be self-sufficient to recover it. So all those kind of building those system, testing it, and then going to the market, that will be difficult. Otherwise, you will have kind of challenges. I have seen those challenges in past. So I did one system, and it was not exactly payment, but it is kind of uh, reward management system. So there was when there's a load, there is some service goes down. It was a partial failure, and it was a loss actually, because people are doing the transaction with the reward, and they are getting the reward without spending the money for sometimes. So when you design this kind of system, means you need to remember that you always design for the failure. So if anything goes wrong, you should not do that.
और सर इंडिया में लोग ज्यादा मतलब शातिर हैं.
So they are spending 0.01, and system is allowing to them to do that, and they are getting 25 paisa reward, and they are keep doing that. So any kind of this kind of means it is a small thing, but I think it impact in a big, because sometimes what happens is some crazy people comes in and they automate it. So they are doing it basically.
कहीं सर यही कारण तो नहीं है कि इंडिया के जितने फिनटेक स्टार्टअप्स हैं सब लॉस में
नहीं, ऐसा नहीं है, बट nowadays the system which is building, there are multiple companies in India now, Paytm or because they are doing in different domains. If you see Paytm, why it is in loss? Because they are doing in the some other domains as well. It is not only payment domain. They are lending domain. They are in movie booking and the other system. Paytm Mall was there. Then they sold all those businesses, and then now they are in kind of profitable manner. They are doing now basically.
Sir, for a lot of people, who are outside this domain, a payment simply looks like a simple transaction.
Mhm.
But under the hood, it's a complex system of validations, integrations, and risk checks. Can you actually walk us through what actually happens in a modern payment flow?
So when we talk about payment system, it comes means normal people say, okay, you swipe the transaction card with your
Ah,
machine and money transfer from one bank to another bank.
ah,
But normally it doesn't happen in the back end. So in the back end, there's a multiple things comes in picture actually. So first thing is come is what actually people involves in that. So if you say entities involved in that, the bank, the customer which comes to the shop,
mm,
that is a one party,
mm,
because they have their account in the bank. So this is their bank is second party,
ah,
and then they're swiping the card on a machine which
mm,
has merchant has. So shopkeeper merchant account is a third party actually.
mm, mm.
Okay, merchant has its own bank from where they get the machine. This is a fourth party.
Yes.
Okay, and then you have kind of Visa. The you can say Visa, Mastercard, or acquirers are there. So that card networks we say them. So card network are basically used to settle the payment between the banks. So we
Yes.
cannot directly, bank cannot do the directly the business. So
Ah,
using these card networks, they do the business. So this is the fifth party comes in picture. And then we have payment processor. So normally the banks or the software providers which do this business, and they connect with the card providers. So they provide the machine as well as the software upon that machine so that card can be read and can go through it. So this is sixth party involved. And the seventh party is the our RBI regulatory companies, or whatever it's like you can say in India. So these are at least six parties are involved as a to data process mainly. So whenever you swipe a card, it takes your details as a merchant details from the card.
mm,
It sends it to the basically it is your processor. The processor is who is going to actually not processing your payment, but it took your data and
mm,
now sending it to the acquirer bank basically, like whether this bank exists or not exist, this account is valid account or not valid account. And then once it is a processor send it to the acquirer bank, what it will do is it do all kind of validations in the background, like merchant exist or not exist, everything, whether this machine is okay with this merchant or not okay. So we do all kind of validation. In parallel, we also run the fraud checks as well
yes. No.
before
Yes.
do that. So
Mm,
that is kind of parallel activity. It is not a kind of sequential activity. So once it is done with the acquirer bank send it to the card network, whether it is a Visa, Mastercard, because they connect with the then customer bank with the merchant account. Okay, we are doing this transaction. This merchant has sent this request.
mm,
Now you need to approve it. Once they approve it transaction, you get the approval of the transaction only, but it
mm,
is not settled. So
mm,
you get the receipt on the terminal, like your payment is processed, it is approved, merchant was valid, there was a balance in the customer account, so we did the transaction. Now there are all the parties, the processor part, the acquirer bank, the merchant bank, customer bank, the network, card networks. So they need to settle this basically. So settlement is a more kind of more complex process in
mm.
in parallel. So like in India, if you say card, they says okay after 24 hours or after 8 hours they settle that money.
Yes.
So settlement is once the settlement has been done and uploaded, then this actual debit has been happened from the account. I'm not talking about UPI because in UPI it is a directly. transactions. So UPI is separate, little bit more different kind of flow because it is a one bank to another bank without any Visa, Mastercard involved. So these kind of means when you develop this kind of systems, it is more kind of a chain of the transactions, and you need to deal all stakeholders because you are not dependent only on your system, you are dependent on the others as well. That's why it is more complex than other systems, basically.
तो सर इसमें ऐसा कभी क्यों नहीं हुआ कि लाइक मास्टर कार्ड इज ए कार्ड कंपनी उनका पीओएस भी मतलब आ सकता था लाइक इफ वी टॉक अबाउट रेजर पे क्या है सर रेजर पे इज ए पॉइंट ऑफ सेल्स
Not point of sales. Razorpay is a kind of, as I say, processor, you can say, mostly. So they kind of provide kind of middle services between them. So there are different companies, like we are also working on transaction service. So everyone cannot connect with Visa, Mastercard directly. That is sure because they have the different guidelines. They have different kind of standard processes. So what there were few companies integrated with Visa, Mastercard, and RuPay card, all card networks basically, and they provided a single uh, interface for them. So that whenever someone is calling it, they can put only one call, and they can distribute this call to Visa, Mastercard, and RuPay card. So that's why these companies comes in picture, Razorpay or other companies who is providing this software.
And when we talk about payments, like, milliseconds matter and failures are not an option. And you have already mentioned that. So how do you design systems that can handle massive transaction volumes while maintaining near zero downtime?
So when we talk about payment system, normally it is a kind of when you develop for when someone is going to get this payment system, they say, okay, I need SLA for 99.99. It means your system need to be can be down only 52 minutes in a year.
Ah,
Okay, around it 52 minutes, I think. Yeah. So, so when you design this kind of system, okay, so every second is matters for them. So it is not only downtime, but millisecond is basically, as I told that there is a chain of reactions. When you swipe your card, it is going to multiple stakeholders. If you see, and each millisecond is required. So, uh, if you need to do the transactions, you are getting the millions of transactions daily basis, or you can say thousands of transaction in per second basis. So you need to make transaction very fast as a large scale, basically. Let's say 200 millisecond within a means when you get 1,000 transaction, you need to process it within a 200 millisecond, and it includes everything, network bandwidth and everything. So when you design it something like, okay, what are mandatory part as a kind of synchronous part of it, and what is part of asynchronous. When I'm saying synchronous, okay, I can wait for response for from these stakeholders, but I cannot wait for response from these stakeholders. So if I am saying, okay, from merchant bank, I am not getting authorized, I cannot do anything further. So that is synchronous part of it. So I'm waiting for his response actually. But if I need to put something on reporting side or fraud detection side, I can do in parallel. So once I get the approved response, I am not going to back to merchant till that fraud detection response is not coming in picture. So if both is coming, I am getting that, then I can say, and then we can send this to in parallel as a synchronous manner to different systems as a database. So settlement can be done later stages, but yeah, few parts which we design as a kind of synchronous versus asynchronous, that is more important when we design it. Second part of it, when it comes as a kind of deployment model as well, when you get systems as a load part of it, so 10,000 transaction comes as a sudden off, like in Diwali sale, if you've seen that. So they design as a system like, okay, as soon as the limit reaches of the hardware, the today's scenario, cloud hits to basically to replicate their servers basically. So they increase the servers on the fly basically instead of doing manually doing anything. So that is the another part. And then most importantly, today's scenario, if you see in today's system, earlier we are using the monolithic system. So single system is going down, everything is going down. Now the scenario is when you design a payment system, you design a domain-driven payment system. So if your one module is getting failed, but still your payment is up,
Hmm.
So, so it is not only single services failing every. So let's say your registration part is failing, but your payment part is still work for existing merchants. So that's how they design it basically. So they design on microservice on domain level basically, so that it can be run without any other dependencies.
Yes. Means every part is kind of running on its own,
Yeah.
uh, with proper authentication verifications
Yes.
communicated between them.
So if you see, means authentication is a part. So whenever device is means normally device is already logged in because device is registered with the merchant name. So when they send this transaction to means on the server side, basically, uh, they have this identity, but it doesn't matter. Sorry, it doesn't matter like if anything is happened on the anything happened on user management side which is not kind of authenticated, you
Yes.
cannot withdraw the transaction. So they
Right.
do kind of systems where they cache it
Hmm.
for their tokens or their kind of authentication database, so that if user management is going down, payment is self-sufficient to run the transaction for some time. Till that user management is not coming back, they
Yes.
do that kind of.
And now, Ashish, with all these tools like Kafka and containerized architectures becoming a standard these days, many teams claim to be distributed fast. So,
Hmm.
from your experience, what separates a well-designed distributed systems from ones that fail at scale?
Distributed first has become one of the terms whether team put very miss they are using very casually actually right now in today's day basically. So they says okay, we have monolithic system, we can build the distributed system very easily. They says okay, it will always improve the things basically. So but it is not the case every time. So monolithic system was okay there, but there was a if there is a failure, there is a total failure.
Uh,
That was their drawback, actually. So when we go with the distributed systems, they need to understand the consequences as well. Because when you have different databases, different services, normally what I've seen is distributed system is when they design it, they create two different applications, basically monolithic application, and they connect it with each other. So we also did that mistake sometimes earlier in the past. So uh, so they define the dependency one on each other basically. So if one is getting failed, another is also getting failed. So problem is not still solved. And you means increase the complexity of the monitoring part of it because distributed system has different databases, different logs. So your asset transaction properties will not be working there. So their database is not consistent. So this is committed, this is not committed. So data is inconsistent between the systems. So normally these scenarios, when they goes to scale, they are system getting failed. Normally, when someone is going to design a system with the distributed, they normally design kind of okay, one service cannot be depend on another service. Okay, one is going down, another cannot be go down with this dependency. If this is going down, it is there should be a way out for that. So they design for those, and when they design for it, they design for its consistency, eventual consistency of the data, so that all system data is synced at least after some point of time, so that you have at least eventual consistent system. Then you have the operational complexity because there you can debug it or you can have the log for in the monolithic system. You have one service log, you know that from where it gets failed. But here there are four services where it gets failed. You need to identify it. So you need to design some way like you say the observability part of it. So we
yes.
kind of write the log from one service to request start from here, travels to B point, travels between 12 services. You need to know, okay, which service gets failed and where it is. So you need to trace it basically. So that is part where most of the teams, I think, gets confused and means when they design it, means mismatch it basically. Sometimes happens. One of my experience, actually, my one of the architect has joined us. So he checked our code base and told us, okay, now your system is dependent on user management. Every service is dependent on user management. It's okay, but some services are means one or two services user management also depend on that.
Yeah.
So it is a cross dependency. That's kind of system when designed, no one is going to check, okay, you need to just make a call. That's what they do to it in the developer limit. But when architects come in picture, they actually guide us. Like, okay, this is not right. This is the way to do that. Second assumption, what Teams is taking is basically on the network side. So when you have the monolithic system, anything gets failed, it is total failure again. But here, when one service, a network getting failed from one service to in between second service, it is not total failure, it's just partial failure actually. So the data is going to inconsistent. So that is again part of, so when you design the system in the distributed system, you need to know the network basis what is going to fail when you need this eventual consistency, when you need this uh, kind of uh, uh, kind of basic properties in your databases, and basis on that you need to decide that. So that is the second part of that. Again, when normally what is happening is basically when we design this kind of system, we ask few questions from us, like, okay, whether this is eventual consistency is acceptable or not acceptable, like in kind of means when you take the authorization of the transaction, you need that at the same point of time, but when you show that data on the dashboard, you maybe it will take some time, so it, eventual consistency will work from there point. Other than that, I think uh, that's it. Means enough means
Hey, this is nice, sir. And now, a very important thing, these days,
Mhm.
there's a lot of discussions that is happening around AI in payments,
Sure.
right? From fraud detection, risk of scoring, personalization. From your perspective, where is AI genuinely creating an impact and where is it basically a hype?
अरे हर जगह पे ही नहीं लगा सकते नहीं, it is okay कि AI is one of the good concept. So there are two part of it. One is it is helping the development part of it.
Yes.
So development is going little bit fast. Second is what it can help with the payment system is if we are talking about payment system. It is not helping much because it is more helping on the fraud detection side actually. Because you can have runtime algorithms for
Yes.
to run fraud detections. Like customer is now in currently first transaction he did in morning in India, now he's doing in the US. So they automatically block that. So same kind of rule dynamically on dynamic basis they are doing that. So that's where the AI coming in picture. Other than that, on payment ecosystem, when you're doing the payment, there is no other use from my perspective. Only the thing is now AI comes when AI comes in picture, they can actually say, okay, ingest the data, and basis on that data pattern, they can predict something. One thing what they are in payment domain, one more thing they can do is right now, what we are doing right now in the smart routing part of it. So when we say smart routing, so when you do the transaction from payment gateway, if you use the Swiggy or something, this shows, okay, this is less failure prone uh, instrument for the payment. This is more success rate. So that kind of flow they can show that. And even you when you do the card transaction, they have in backend, okay, so there is a called MDR. So merchant pays some fees to the bank when they use this kind of transaction. So if bank is same which customer card bank, so MDR is very less. But if his bank is different, MDR is different. So what nowadays is a smart payment system is doing is if they are swapping with the ICICI card, they can in backend they can transfer this to the ICICI bank basically instrument. So they have multiple accounts, and so that they can route different account basis on that, so that they will use the less MDR. Those kind of system AI can means improve that. Other than that, I think only the data ingestion and data like merchant is using or machine or not using, how much transactions are coming basically on that. So on that part, AI is doing good job. Like if you've seen some kind of you can say reward management system where they can say, okay, you can utilize in this reward in this category, then you will get more reward or something like that. So there you can get, but on payment, I think these two are main part, fraud detection part and the smart routing part. Yeah, main part.
And now the last one is that as AI becomes a part of engineering stack itself, and you have touched upon like development times have been reduced,
Mhm.
thanks to AI, but a lot of other problems also coming up that we can also discuss. It's there, like the quality of code and all that breaches and all. So, so how do you see the role of backend engineers evolving in the next few years?
देखो अभी अगर हिंदी में बोले ना तो कि पहले क्या होता था कि डेव आते थे हमारे पास वॉट एवर डेव्स कम्स इन पिक्चर दे आर देयर मेन जॉब इज डूइंग द कोडिंग
हाँ.
they are just coder kind of part of it. So you give them a script. Sometimes I remember when I started my career, some companies used to give them a pseudocode as well to develop that in a particular language. Now a time is basically developer need to understand the code only. So they need to understand reading the code, how code is going to flow it, and they need to basis on that they need to decide what action need to be taken. They do not need to write much code on that, but that AI is going to do that. But once they will able to understand that code, they can find out the issues with that code. So now going to be developer will not be only developer writing the code. They are going to be system designer. So they will kind of hold end-to-end responsibility from building to deployment and the monitoring of that. So that will be their responsibility because coding will be kind of very going to be labor job, and that is going done by the UI. Most means if you go today, uh, if you define your problem correctly to AI engine, they write down the code.
Yes, yes.
But only the challenge is once it is getting stuck in somewhere, you need to understand how to get wheel out of that mud. So that is the developer's job is going to be because I've seen that. I mean, first, so I have a one experience. One developer has written down all the APIs through the AI engine. Now code is generated, it is working. Someone is asked, okay, do you understand this code? Then the problem comes in actually. If says, okay, if it is not maintainable in future, you cannot change anything in this code. So you need to simplify this. So that is the only problem. So I think that's why the developer need to change little bit more now in terms of instead of writing only the code, they need to be designing the code as well as understanding the code better. Other than that, I think their job is not going to impact much, but yeah, means
कॉलेज में ज्यादा पढ़ाई करनी चाहिए पड़ेगी सर इनको.
हाँ मतलब अब वो नहीं चलेगा ना कि सिर्फ सिंपल सा लूप लगा दिया एंड इट इज गोइंग टू बी वर्क फॉर यू. You need to understand that and you need to understand how AI is going to use. So you need to orchestrate the human AI plus system design, all three things as a part of it to design and give it a better shape. So,
मतलब जो कॉलेज से निकल के सर पहले साल में जो नौकरी लगी वो 3 साल एक्सपीरियंस्ड होके उसको कॉलेज से
करेक्ट वो उसे होना होगा मतलब पहले क्या होता था इवन आई वाज व्हेन आई मींस met one of the my colleague in first company. He told me like, okay, you need to write the code in notepad instead of any kind of if you learn if you want to learn actually coding, because that notepad and when you run your program in the notepad from notepad to your studio, so at that time, you should not get any error. That mindset should be there in their system because I learned this from when I joined the job after that. So, but nowadays they need this mindset from the actually college itself. That's why it is going to be more difficult for them. And it is not kind of now it is thinking job instead of only labor job.
Thank you so much, Ashish, for joining us and sharing all these insights. Lovely conversation. I know we touched up.
Thank you. Thank you, Vishnu. Thank you.
Ashish, thank you so much for your time.
Thank you.